Hi, Nick McQuaid here to go through a short R tutorial. This is from the book R in a Nutshell, and it's the sections. I'm just going to do the sections, the first three sections of Chapter 3, Basic Operations, Functions, and Variables, and I'll stop there. And I may, in a later video, go through the rest of the sections of this tutorial, or you may go through them on your own. I'll ask you for some feedback about how we should arrange that. So let's begin by taking a look at my R environment. So what I have here is I have R running in a terminal window connected to a text editor window. The text editor I'm using is Vim, and I'm using a plugin called nvim-r, and that's nvim-r, formerly known as vim-r. But recently its name changed because it became compatible with NeoVim as well as with Vim. And this plugin allows me to type stuff into, among many other things, it allows me to type stuff into a file in my text editor and then send the material that I type in to an R window for computation. So for example, the very beginning of the tutorial is basic operations, and the very first thing that happens is that the author stunningly adds 1, 2, and 3 together. So I'm going to do that now. And what's happened is when I press the key to send this to the R interpreter that's running, it appeared over here, and output appeared here. And this output is simply the result of this expression being evaluated. So this is a read, evaluate, and process, or read, evaluate, and print loop, and it does this evaluation one expression at a time. And it can also evaluate scripts. We can use scripts this way, but there are other ways we can use scripts. So this, but I'm getting ahead of myself if I talk about scripts. All I want to do is talk about some very basic things. So the most basic thing that you can do with R is use it as if it were a calculator. So you can do arithmetic expressions like 1 plus 2 plus 3. The next expression I'll do is 1 plus 2 times 3. And you'll notice here that the multiplication operator binds before the addition operator. So we have 1 plus the result of 2 times 3. And I would have to use parentheses in order to make the plus bind before the times. This is vector notation. Now, if you've been following through the first few videos, you know that vectors are going to be an important part of this course, and the way that R produces a vector is with the combine or concatenate function here. And here we're combining the first few numbers of the Fibonacci series, and the result is a vector, the vector 0, 1, 1, 2, 3, 5, 8. Now I mentioned in a previous video that vectors are interpreted as columns in the textbook. R actually assumes that your vector is either a column vector or a row vector, depending on what makes more sense. So the fact that this appeared to be a row vector rather than a column vector is kind of illusory. If you try to multiply a row vector times a column vector and they're the same length, that's a correct operation in linear algebra. But if you were to try to multiply 2 row vectors, say a row vector like this times itself, that would be an incorrect operation in linear algebra. But R assumes that what you meant was to multiply a row vector times a column vector. So you'll see R is a bit more relaxed about the rules of mathematics than a linear algebra textbook might be. Okay, the next thing I'm going to enter is actually a sequence of numbers from 1 to 50. And you can see that that's a little bit inconvenient. It sort of has gone off the edge of the screen here. Oh no, it didn't. It's fine. But it could have gone off the edge of the screen, and so that leads me to want to change the width of the screen. And here's an option that I can give to R. This isn't part of the tutorial, but this is an option I can give to R to make the width of the screen seem smaller. It also, the screen may seem to get cluttered, so there are options for clearing the screen. This option allegedly works on Windows. It doesn't work on my display, as you can see, but if you're running on Windows, that may work. This option will work to clear the screen on my display. And now if I do this command again, you'll see that the lines are shorter. The lines are only 60 columns long. And this brings me to something that's mentioned in the tutorial that I haven't mentioned so far, which is that the output has numbers in brackets next to it. And the numbers in brackets refer to the index number of the item right next to it. So if your results are a single number, you'll always have a 1 in brackets next to it. But if you have a whole bunch of things, you'll have multiple rows potentially. And so this is the 19th item. Now, because I did this 1 to 50, it also happens to be the numeral 19, just as this is the numeral 37. But these numbers here refer to positions. So I would get exactly the same result. Let's say instead of 1 to 50, I did 50 to 1. And I get the same indexes. The first one is 1. The second row, the first element is the 19th element. And the third row, the first element is the 37th element, even though these aren't the same numerals. Okay, and this is, again, is not in, these few commands are not. In fact, this should illustrate to you something that I want you to do when you're working with R. When a question occurs to you, don't just keep necessarily blindly going through the tutorial. Stop and think about things, think about what things might mean. So the next few commands in the tutorial involve adding vectors together, which I'll do now. I'll add these two vectors together, and you can see that what's happened is that the result has been a new vector, a new 4-element vector. The first element is 10 plus 1, the second element is 20 plus 2, the third element is 30 plus 3, the fourth element is 40 plus 4. And now the same thing with multiplication. And by the way, here again, R is assuming that we're multiplying a row vector times a column vector. So if you are into linear algebra, this could seem a little relaxed. Subtracting one vector from another vector. Now we get into something a little bit more interesting. Suppose that I want to add a scalar or a numeral, a single number, to a vector. So I'm going to add the number 1 to this vector. And the result is a new vector that has had 1 added to each element of it. So this is very important to be able to do scalar addition, subtraction, multiplication, and division. And here is an example of scalar division. So I'm going to divide 1 by each element of a vector, and you can see the result is in this case, a 5-element vector, 1 over 1, 1 over 2, 1 over 3, 1 over 4, and 1 over 5. And it's an annoying vector to me because it's got too many zeros in it, too many decimals, too much precision in it. So this leads me to give another option to R. Notice that I gave an option to R here. I'm giving another option to R here. The option digits 3 is going to allow me to do this again, and I only get 3 decimal places. There's 3 positions after the decimal point, which to me just looks better. It doesn't change the underlying, this representation on the display doesn't at all change the numbers that R is storing, by the way. Let's see, where am I? Now here's another interesting property. Now in addition to multiplying or adding or multiplying or dividing a scalar by a vector, I can add a short vector to a longer vector. This would be illegal in linear algebra, but what R is doing is it's extending this smaller vector to match the length of the larger vector. So when R does the addition, it first adds 1 to 10, it adds 2 to 100, then it reuses this vector, adds 3 to 10, and 4 to 100. And the same thing is going to be true if I do this, except here's a problem. What happens if the larger vector is not a multiple of the larger vector is not a multiple of the smaller vector? So it did exactly what I asked, but it also issued an error message, or warning, not an error message, a warning message. So there are different severities of messages, and you have to treat these messages differently. So this was a warning message, not an error message. The warning message was that the longer object length is not a multiple of the shorter object length. I can also enter strings, and this particular string is called a character vector of length 1. And here's a character vector of length 2. This is actually how R handles strings, is it refers to each string as a vector. And so there are just 2 elements here. Now, this isn't in the book, but I just wanted to make sure that you understood that these would show up with the index numbers 1 and 2 if they were long enough. So I've added a couple of extra, or I guess I've added 1 extra copy of this. So let me show this character vector of length 4. And what's happened here is that R is depicting it as a vector element here that's string number 1, character vector number 2 here, character vector number 3 here. So this index refers to this being the third element, element in this, the third element of output here, the third character vector in a vector of character vectors. Okay. R has comments, so here's a comment. Comment is preceded by a hash mark or a splat or whatever you call it, and a comment can come after a line. And in the tutorial, it's shown as in the middle of a line, and that's a little bit misleading because once the comment character appears, there can't be anything else on the line. But I could move this +3 down to the next line, and then this wouldn't be, or no, I could just move the 3 down. Let's say I move the 3 down. This wouldn't be completely evaluated until I got down there. So I could have a comment in the middle of an expression if I split the expression into multiple lines. But I don't really have a comment in the middle of a line, in the sense that a comment character causes everything till the end of the line to be interpreted as a comment. Okay, now R does a lot with functions. Everything is a function in R, it seems. And so let's look at some simple functions. So here's the exponential function, e raised to the first power, which is, of course, e. E raised to the 0th power, which should turn out to be 1. Now, one question I have in a lot of programming languages is there a constant already defined for like e and pi and other important constants like that? So I checked with this one, and no, there's object e not found. Now, I could just create one myself. Obviously, I could just say e gets exp1. And now if I say e, I'll get e. There's a cosine function, and here's the cosine of pi, which should be, I don't know, -1, okay. I don't think we'll use cosine function very much. We certainly will use e. We certainly will use logs. Here's log to the base 2 of 1. Here's log to the base 4 of 64. Oops. And here's a shorthand way to say log to the base 4 of 64. Now, notice here that we have a function arguments in R have both positional importance and assignment possibilities. So by default, the first argument is usually x, but we've specified it here. we didn't really have to because it's by default the first argument. By default, the second argument to log is base. So we didn't really have to specify that. But most of the other arguments, many arguments that we'll encounter, are not positional, and we have to do a mapping of the argument to the argument name. And we do that mapping exclusively with this single equal sign. We can use, as an assignment operator, we can use either the equal sign or this less than sign followed by a hyphen. We can use this or the equal sign as an assignment operator, but not in a list of function arguments. In the list of function arguments, we should use this. We can get lucky and this will work. There are some cases where this will work inside here, but not necessarily. Okay, and addition is a function. So when we did this, when we did these addition things, those were functions. If we raise a number to a power, such as 2 to the 10th, that's a function. If we check for equality, so notice that the equal sign has already been used up as an assignment operator, so we can't ask if 3 is equal to 4 with a single equal sign. As in most C-inspired languages, we're going to use a double equal sign. And in this particular case, the result is false because 3 is not equal to 4. So that is an expression, 3 equals 4, and the value of that expression is false. When that expression is evaluated, it returns false. And the textbook doesn't show it, but I would like to know what happens if I put in an expression that is true. So I put in 4, does 4 equal 4? And indeed, it returns true. By the way, you may notice that all this stuff is colored. So I'm using a syntax highlighter in my text editor, and I'm also using a syntax highlighter in my terminal window. And these are things that I find useful. You may or may not. I often find that beginners do not like syntax highlighting because they don't understand it. And after a while, syntax highlighting becomes necessary and you can't make do without it. So do what feels comfortable for you. If syntax highlighting at first does not feel comfortable for you, then don't do it. And then eventually it's likely that it will become preferred for you. And syntax highlighting for R is available in all full-featured text editors. I mentioned in a previous video that I want you to use a full-featured text editor. I don't want you to use Notepad or Pico or something like that. So I want you to have the ability to do things like a plugin for the text editor that allows the R expressions to be sent to R, and syntax highlighting and other features. Okay, the next section in the tutorial is on variables. So we can assign things to variables we can assign values to variables in R. So I'm going to assign the value of 1 to X and the value of 2 to Y, and then I'm going to assign X and Y to Z, and now Z is a vector of length 2, and the two components of vector Z are 1 and 2. And now I'm going to reassign Y, so now Y is equal to 4, and you might wonder, what will Z be equal to? And indeed, Z is still equal to 1 and 2. So what's happened is we haven't sent a pointer to Z to whatever is at the address of Y. Instead, we simply sent the value that was then Y to Z. So Z has no memory of where it got that value. It simply has that value. And if the variables that were used in assigning are changed, it doesn't really matter to Z. Okay, now here's a much longer vector. Vector B here has 12 elements. And if I say B, I get back those 12 elements. And I could also, that particular vector happens to be the numerals 1 through 12. And so I could use the sequence operator and get the exact same result. So I have a vector of length 12 containing numbers 1 through 12. And I can refer to the positions within vectors by indexes. And these indexes are the same as the indexes that you see in the terminal window. They're enclosed in square brackets. So B7, as you might guess, is the numeral 7. It is what was in the 7th location. B1 through 6 are the items in the first 6 locations. And as a special plus, I can put more elaborate expressions into that index. So what is that expression? B modulus 3 is equal to 0. So this is an expression, and I'm just showing you the expression by itself. This expression evaluates to false if b modulus 3 is not equal to 0. So that's going to return multiples of 3. And you can see here, if we speak through the numbers, false, false, true, that's 1, 2, 3. So 3 was true. 4, 5, 6 is true. 7, 8, 9 is true. 10, 11, and 12 is true. So only the multiples of 3 are true. So and I can put any kind of expression that I want in there. Let me just do one more expression before I move on. Let's say B. Can I? Actually, I can't even remember now if I can do it like this, but I think I can. Let's just see what happens if I do that. Oh, no, I can't do that. I want, how do I go B greater? B modulus 3. So maybe I can do this. If I do that. Oh, okay, so I can do that. B is greater, B where the current index position of B is greater than 10. I'm a bit rusty on this. Okay, and then I can choose individual components in any order. So here I've chosen, but I have to show them as a character, I have to show them as a vector. So I have to use the combine or concatenate operator. So I can get elements 1, 6, and 11. And these are positions 1, 6, and 11. So let's suppose that I make, let me just do B gets C 12 to 1. And I'm just going to do this again. And I'm still getting positions 1, 6, and 11, and positions 8, 4, and 9. But because the actual vector is rearranged, I'm not getting those same numerals. So I'm just doing that because I think that it can be confusing when the indexes happen to be equal to the values at those indexes. Okay, and so here's a variable 1. I'm assigning the numeral 1 to it. Here's a variable 2. And then I'm assigning 2 to 1, and now I'm going to look at 1 and look at 2, and they're both 2. Now notice here that I've used the assignment operator. Here I'm using the equals operator, and indeed 2 is equal to 2. Whew, that was a lucky break. So let's do it again. Let's start over, and now let's see if 1 is equal to 2. And oh yes, 1 is not equal to 2. Good. And this assignment operator, the hyphen preceded by the less than sign, can be turned around. So if I do this, I'm able to assign the value 3 to the word 3 by turning that operator around. And the textbook makes mention of the fact that sometimes you'll type in a long expression and suddenly realize at the end of the expression that you wanted to assign it to a variable. And so this turning this around can come in handy in a moment like that. We can, of course, create our own functions. And here's the creation of a function. We're creating function f, and we're doing that by assigning f the value function x of y, and here's the body of the function is inside curly braces. And so inside curly braces, the parameters x and y each have 1 added to them, and the object that's going to be returned is going to be a vector consisting of x and y each with 1 added to it. So let's instantiate this function. And with 1 and 2, with x and y as 1 and 2, with x and y as 1 and 2, we get 2 and 3. A vector, that is to say, containing the components 2 and 3. Now, what is f? If I just say what is the value of f without anything behind it, what shall I get? I'll get the function definition. Okay, so that's it. That takes us right up to the end of the variable section in the short R tutorial that is chapter 3 of R in a Nutshell by Joseph Adler. So the remaining sections are objects and classes, models and formulas, charts and graphics, and getting help. And I may or may not do a video of those. I want to hear from you whether it's worthwhile for me to go through this or whether you prefer to just go through it in the book. Thanks for listening.